Hello, we're the EPRI WELDS team, and our project is for the Electric Power Research Institute, and it is to design a proof of concept method to assess welding quality.
The objective is to find a way to detect weld defects using sound or vibration, then use data to provide real-time feedback to the welder using a feedback loop. EPRI wanted to use sound and vibration in order to get better weld quality. High wire feed and low wire feed were assessed in testing. Microphones are used to detect high wire feed defects, and accelerometers are used to detect low wire defects. Data from both sensors were used to develop a feedback loop to show when defects are.
Here are the requirements and verifications for the EPRI WELDS design project. One such requirement is design and create a testing apparatus which will be used in order to obtain data to evaluate weld quality. And one such verification is utilize a combination of Python and LabVIEW in order to collect and analyze data in an FFT.
The microphone design consisted of a holder mounted to the weld head in order to record any significant sounds each type of weld may produce. This holder was initially 3D printed out of PETG plastic and will be 3D printed out of aluminum as a final product. Data collected from the microphone was recorded as a WAV file for the team to efficiently analyze every test run. Microphone data was analyzed by using MATLAB software, which was able to plot the entirety of each WAV file as a spectrogram. For comparison, normal weld data served as a baseline to show discrepancies from any weld defect. Using microphones, the team successfully identified a weld defect during testing. The accelerometer design featured two accelerometers. One accelerometer was placed on the weld head to be used as a reference to the second, which was placed on the wire feed itself using a holder designed by the team. The holder was 3D printed with PETG plastic in order to allow free movement of the wire feed for weld quality detection. The team collected data from both a normal weld and low wire feed weld defect into CSV files for future analysis. Normal weld data was used as the baseline when comparing both sets of data. When viewing both sets of data, the team successfully concluded that the weld defect was identified using the accelerometer method of detection. The current sensor design mainly consisted of using a current sensor to monitor the current draw of the wire feed motor during welding in hopes of detecting any patterns for each type of weld. The data collected from this method was stored as a CSV file and further analyzed to assist the team in the sensor's effectiveness. The team was able to successfully view the behavior for both a normal and low wire feed weld, but no differences were able to be determined based on the motor's current draw. The team decided that the use of a current sensor would not be useful for the project moving forward.
The team has concluded that it is possible to detect high and low wire feed defects using sound and vibration equipment, and has created software to give a warning when the defect is occurring to the welder in real time. A prototype that was built by the team has been turned over to EPRI with all data and data analysis code. The team came in under budget, spending only $880 of their available $3,000 funding. The application of this project will be used for quality control purposes in nuclear power plants' welding operations.